We have now definite integral of absolute value of 2y minus 3 with respect to y. So the only way that we can do this problem is to get rid of the absolute value. We need to use definition of absolute value. Let me remind you, when we have absolute value of x, this is equal x if x is greater than or equal 0, and we have negative x if x is less than 0. So now we have to first rewrite our absolute value. We have absolute value of 2y minus 3. This is equal. First, we have to just copy whatever is between absolute value bars. So we have 2y minus 3, and this is for 2y minus 3 greater than or equal 0. Whatever is between absolute value bars must be greater than or equal 0. And the second part, we have to put negative sign before expression between absolute value bars. So we can put this in parentheses, 2y minus 3, and this is for 2y minus 3 less than 0. Now we have to solve these two inequalities to determine where the quantity on the inside of absolute value bars is negative and where it's positive. So let me solve this inequality. So it will be 2y is greater than or equals, I will move negative 3 to right side, so it will be 3. Now we have to divide both sides by 2. So we will have y is greater than or equals 3 over 2. This is 1.5, yes? And the second, we have to only change the sign. So it will be y is less than 3 over 2, because we have the same expression on the left side of our inequality. Now, when we have value of y, we can rewrite our absolute value one more time. Absolute value of 2y minus 3 is equal 2y minus 3 for y greater than or equals 3 over 2, and we have negative sign, so we need to change the sign inside parentheses, so it will be negative 2y, negative and negative give us positive 3, and this part is for y less than 3 over 2. Now we can rewrite our definite integral to sum of integrals. Because we have interval from 0 to 4, let me write this. We have x-axis, we have y-axis in this case, because our integral is with respect to y. So we have interval from 0 to 4. For y equals 3 over 2, our expression change. First, for y less than 3 over 2, we have our function negative 2y plus 3. And for y greater than 3 over 2, we have 2y minus 3. So we need to find 3 over 2 is 1.5 approximately. You can write here is 1.5. This is equal 3 over 2. So we see that we have to divide our interval to two intervals. First is from 0 to 3 over 2, and the second is from 3 over 2 to 4. Interval from 0 to 3 over 2, we need to use this formula, because this formula is for y less than 3 over 2. So for this part we have negative 2y plus 3, And for value greater than or equals 3 over 2, we have y 2y minus 3. So now we can rewrite our definite integral from 0 to 4 of 2y minus 3 dy, that this is equal to sum of integrals from 0 to 3 over 2. And for interval from 0 to 3 over 2, from 0 to 3 over 2, we have, let me put this in parentheses, negative 2y plus 3. Our integral is with respect to y, plus, now we have integral from 3 over 2 to 4. And for this interval, we need to use expression 2y minus 3. So we see, I'll just rewrite our definite integral from 0 to 4 to two integrals, from 0 to 3 over 2 and from 3 over 2 to 4. I just use property of integral. Now we have to just solve these two integrals. So this is equal. We have here in parentheses addition. So we know that integral of sum is equals to sum of integrals. So we need to calculate integral of negative 2y. And next we need to calculate integral of 3. So integral of negative 2y is, we have to copy constant, and integral of y is y square over 2. I just use integral of power function formula. We have here invisible 1, so I need to add 1. 1 plus 1 is 2, and the numerator is always the same like exponent. Plus, we have now constant, we copy constant, and integral of dy is y. First integral has limits. Upper limit is 3 over 2 and lower limit is 0. We have plus, and now we have first integral of 2y. Integral of 2y is, we have to copy constant, and integral of y is y square over 2 minus, and again we have to copy constant. We have now integral of dy. Integral of dy is y. The second integral is from 3 over 2 to 4. Now first we can simplify. We will reduce 2 and 2. So we have negative times positive is negative. So this is equal negative y square plus 3y. And our limits is from 0 to 3 over 2. 2 and 2 we can reduce, and we have plus y square minus 3y. And we have limits from 3 over 2 to 4. I will put this in parentheses because these limits, first we have to this whole expression put these limits, and for this second expression we need to use these limits from 3 over 2 to 4. So this is equal. Now we have to plug first upper limit. So it means we have to replace y by 3 over 2 first. So it will be negative sign we have to copy, and in parentheses we will put 3 over 2 square plus 3 times 3 over 2. Let me put this in parentheses, minus. Now we have to subtract the lower limit, so we have to replace y's by 0. So it will be negative y square, so it will be negative 0 square plus 3 times 0. plus, and next we have to plug first upper limit to this expression. So we have plus, and I will put this in parentheses. It will be y squared, so will be 4 squared minus 3 times 4. And now we have to subtract the lower limit, so it means we have to replace x's by 3 over 2. It will be 3 over 2 squared, and because we have again negative, so I will put this in brackets now, minus, you have 3 times 3 over 2. Close parenthesis. So this is equal. We have negative 3 over 2 squared is 9 over 4. And we have plus 9 over 2 minus 0 squared plus 3 times 0 will be 0. So this whole expression we can cancel. And we have plus 4 squared is 16 minus 12. And we have negative sign before the bracket. So let me put this in parentheses now. 3 over 2 squared is 9 over 4 minus 9 over 2. So this is equal. We can change this to the same denominator. So it will be times 2 times 2. So it will be negative 9 over 4 plus 18 over 4. 16 minus 12 is 4. Minus, and we will have 9 over 4. And negative give us positive, and we need the same denominator, so I multiply the same by 2 like here. So it will be 18 over 4. So this is equal negative 9 over 4, and negative 9 over 4 is negative 18 over 4, so we can reduce this with 18 over 4, and we have 4 plus 18 over 4. So let me put first 4, and we will change improper fraction to mixed numbers, so it will be 4 and 2 over 4. So this is equal 8, and 1 over 4 is 1/2. This is my solution.